Good morning everyone, my name is Ananya. Today I'll be explaining round robin scheduling algorithm. It's a preemptive algorithm in which each process is executed turn by turn and it is given a particular time slice. In this example, we have the quantum time is equal to 4 seconds. So as we can see the arrival times of each process, P2 arrives first at 0 second. Hence it is executed first. So P2 is executed for 4 seconds and the remaining time for P2 is 3 seconds. Now, next enters P3 at first second and the burst time is 9. So since the quantum time is 4, P3 is also executed for 4 seconds. So this is 4 to 8 and the remaining time for P3 is 9 minus 4, 5 seconds. And next enters P1 and the burst time is 8. So again 8 minus 4 is 4 and P1 is executed for 4 seconds, 12. Next again P2 is executed and the remaining time is 3. So P2 is executed for 3 seconds and the P2 execution is completed. So we have only P1 and P3 left in the ready queue. After P2, P3 is executed again and since the remaining time is 5, it is executed for 4 seconds again and the remaining time is 1. So P3, it is executed from, this is 15 to 19 seconds. Again we execute P1 and P1 has exactly 4 seconds, so we execute it for 4 seconds. P1 19 to 23 and the remaining is P3, it is executed for 1 second, P23 to 24. Now we calculate the completion time, turnaround time and waiting time. So the completion time for P1 is 23. Completion time for P2 is 15 and completion time for P3 is 24. And turnaround time is completion time minus arrival time, which is 21, 15 and 23. And waiting time is turnaround time minus burst time, which is 21 minus 8 is 13 and 15 minus 7 is 8 and 23 minus 9 is 14. After calculating turnaround time and waiting time, we calculate the average turnaround time and waiting time. So here average turnaround time is equal to 21 plus 15 plus 23 by 3 and the answer is 11.66 units. And now average waiting time is 13 plus 8 plus 14. 13 plus 8 plus 14 divided by 3, which is equal to 19.66 units. Okay, here we have another example for round robin scheduling, but here we have all the arrival times of the processes as 0, which means all the process enter the ready queue at the same time, and we have the time quantum is equal to 2. So now we start with P1 and since the time quantum is 2, it is executed for 2 seconds. So in the Gantt chart we write P1 0 to 2 seconds. Next we execute P2. So the remaining time for P2 will be 1 and it is executed for 2 seconds. And P3 remaining time is 3. Same executed for 2 seconds, 4 to 6. Now again we execute P1. So since the remaining time is 2, the execution for P1 is completed. P1 6 to 8. Now P2 we have 1 second and so we execute it for 1 second. P2 8 to 9 and the remaining time for P3 is 3, so we execute for 2 seconds and the remaining time is 1. So P3 9 to 11 and the only remaining process for execution is P3, which with the burst time 1. So P3 11 to 12. Now we calculate completion time, turnaround time and waiting time. Completion time for P1 is 8 seconds. Completion time for P2 is 9 and completion time for P3 is 12. Now as we already discussed, turnaround time is completion time minus arrival time, which is again 8, 9 and 12. Waiting time is turnaround time minus burst time. So 8 minus 4, 4, 9 minus 3, 6, and 12 minus 5, 7. Now we calculate average waiting time and average turnaround time. Average turnaround time is 8 plus 9 plus 12 divided by 3, which is equal to 9.6 units. And average waiting time is equal to 4 plus 6 plus 7 divided by 3, which is again 5.6 units. 5.6 units. So now we have another example in which we have context switch time. Context switch time is the amount of time between each process after execution. So here we have arrival time 0, which means all the process enter the ready queue at the same time. So we start with P1 first. So since the time quantum is 3, each process executes for 3 seconds. So 3. Then, so basically context switch time is after every process. So 3 to 4 we have context switch. So the remaining time for P1 is 5. Then we have P2 till 6 seconds. Then context switch. And this is execution completed for P2. Then P3, the remaining time will be 4 seconds and executes for 3 seconds. So 7 to 10. Again context switch. Then P4 executes for 3 seconds, 11 to 14. Then context switch till 15 seconds. Now we have P5, the remaining time will be 2 seconds. So P5, 15 to 18 seconds. Then context switch from 18 to 19. Now again we start with P1. So 3 seconds and the remaining time will be 2 seconds. So 19 to 22 is P1 execution. Again context switch. Next we have P3 for 3 seconds, so the remaining time will be 1. So P3, 23 to 26. Then context switch till 27. Now we have P5 from 27 to 29. Again context switch till 30. So this execution is completed. Again P1 we have from 30 to 32. This execution is completed and it leaves us with P3. So after context switch till 33, we have P3 finally till 34. So now after the Gantt chart, we calculate completion time, turnaround time and waiting time. So the completion time for P1 is 32. Completion time for P2 is 6 seconds here. And um, P3 is 34 and P4 is 14 and P5 is 19. So now turnaround time is completion time minus arrival time. So it will be the same as completion time since the arrival times are 0, 32, 6, 34, 14 and 19. Waiting time is turnaround time minus burst time, which is 24, 4, 27, 11 and 4. So after this we calculate average turnaround time and average waiting time. So average turnaround time is equal to 32 plus 6 plus 34 plus 14 plus 19 plus 14 plus 19 divided by 5 and we get 23 seconds. 23 seconds. And now we have average waiting time. Average waiting time is 24 plus 4 plus 27 plus 11 plus 4 divided by 5, which is again 14 seconds. Thank you for listening. Hope you understood how to solve round robin scheduling algorithm.